Kinetic energy and gravitational potential energy. Where does kinetic energy come from? An object has kinetic energy when the object is moving. The faster it moves, the more kinetic energy it has. But how does an object get that kinetic energy? We know that the energy must come from somewhere else. Where? It turns out that there are two answers. The kinetic energy of an object can come from work done on the object, such as the work done by the engine to accelerate a car, or potential energy in the object, such as the gravitational potential energy of a ball due to its height. Here's the work energy formula. Initial energy plus work is final energy. This tells us that if an external force does work on an object, the energy of the object will change, and it will change from initial energy to final energy. So work can provide kinetic energy. EI, E initial, plus work is EF. In the chapter on kinetic energy, we found that the work energy equation for an object accelerating from rest, where you start with zero initial energy, to a velocity v, where your final energy is equal to kinetic energy, it's all kinetic energy, that will reduce to work equals KE final. So work from an external force provides a kinetic energy. Is there another way that an object's KE can be increased? Sure is. Think about it and go to the next slide when you're ready to see it. Hopefully you remembered from a few slides ago that GPE can provide kinetic energy. Start again with the work energy formula, and if there is no external force to do work on an object, the energy of the object can't change. So the initial energy has to equal the final energy. The energy must come from another form of energy that was there in the beginning. The energy that was there in the beginning was the energy of its position, gravitational potential energy. The object up here at time 0 seconds is above the ground, so it has GPE. So the initial energy is GPE initial. When the basketball here gets to the bottom, at our reference frame for GPE, that's 0. So it has no more gravitational potential energy. Where did all that energy go? Well, this ball kept getting faster and faster, so the energy went into kinetic energy. So the ball's initial gravitational potential energy provides its kinetic energy as it falls. Here's the equation. We'll be using that to solve problems. Now you may say, but wait a minute, isn't gravity doing work on the basketball? Why are you saying that it's energy and not work? Well, that'll come in your more advanced physics courses again, but we're taking account of that gravitational force by associating it with a gravitational potential energy. So the force of gravity is turned into this gravitational potential energy. So the drop ball example demonstrates the principle of the conservation of energy. The work energy formula tells us that if an external force does work on an object, the energy of the object will change from E initial to EF. When there is no external force doing work on the object, the work equals 0 and energy is conserved. And one more time on this gravity business. The fact that the gravitational force is doing work on the basketball, we take that into account when we talk about gravitational potential energy, so we do not consider that an external force. An external force would be something like friction, perhaps, slowing the ball down when it fell, or if, as the ball was falling, somebody struck it and moved it. But gravity, don't worry about the force here, we're taking care of it with GPE.